Okay, so here is your model. So let's start with the one that you just did. Explain to me what's going on here at the beginning. So we got the no seatbelt, and then we got the seatbelt. And this first part, you started talking about Newton's first law. So what were you?
Well, with Newton's first law, it's the law which states that an object in motion will stay in motion unless affected by an outside force. And so, since the dummy in the car was moving the dummy along with it, and once the car crashed into the wall, the dummy kept moving because it was still in motion. So, and it hadn't yet been affected by an outside force, so it would keep moving until it would hit the steering wheel or windshield.
Okay, and so that's what you said, that in this one, since there's no seatbelt thing, that the dummy is going to keep going forward. Okay, and then how is the situation with the seatbelt and the airbag different?
With this one, it's different because there are now objects interfering it from continuing in motion. This is where the second part of the saying, unless affected by an outside force, comes into play, because it is now being affected by the seatbelt and the airbag, which is causing as like a barrier from it to keep moving forward.
Okay, so let me ask you a couple questions with this. So these arrows, I saw that you drew 2 arrows here on the dummy. What are those representing?
One of them was meant to be the seatbelt, the other was meant to be the airbag.
Okay, and which way are those forces acting?
They're going against the opposite of motion on the dummy, because the car would then later be propelling backwards, but it hasn't yet, so it's technically going opposite in the direction of motion.
Okay, so what would that make the dummy do then in this case?
It would make it slow down and then eventually stop.
Okay, and then in the case without the seatbelt and the
thing,
I noticed you just drew 1 arrow here.
I put drag as an idea. I wasn't exactly sure what else to put, so.
Okay, and so drag would be coming from what?
Would be coming from it going the motion through the air, or.
Okay, so if something is moving through the air, there's going to be a drag force on it.
Mm-hmm.
And what direction is that drag force going to act?
Also opposite in the direction of motion.
Okay, so it's also going to work to slow it down?
Yes.
Okay, so how would the forces on this dummy compare to the forces on this one in terms of the, if I look at the size of your arrows, it seems like...
It's different because there's not, I don't want to say a larger force, but a larger force, because...
Which one has a larger force?
I would think... I was always confused on this part. I believe the larger force is actually supposed to be on this one, but...
On this one?
It's on that one.
That's what you're saying? That's what you guess?
Yeah.
Okay. And why do you think this would have a larger force? Why do you think... And you said these were from the airbag and the seatbelt.
Because it's stopping quicker. It's slowing down quicker, as we can tell, because this one will continue to move in the direction of motion, but is being slowed down at a slower rate.
Okay. So if we redrew these and you wanted to show that this one had a larger force than this one, how might you show that?
I would make the arrows longer.
Make the arrows longer on this one or this one?
On this one, if I wanted to show that it had a greater force.
Had a larger force. Okay, great. Now when we get down to here, you're looking at Newton's second law and possibly Newton's third law. So why don't you tell me what's happening in these 2 situations in terms of what's going on with the crash?
Well, with the second law, it's about mass. I don't know how to exactly say it, but I know that it's the mass will carry a person forward. So like if it has a larger mass, it'll take a longer time to start up and slow down. But with a smaller force, it's easier to speed up and to slow down, so it's easier to accelerate.
And you said smaller force, but you were talking about mass. So do you mean force? Smaller mass. Okay. So with a smaller mass, it's easier to speed up, and with a larger mass, it's harder to speed up or slow down. Okay. How is that applicable? Are the masses of the things in here different for these 2 situations?
Not exactly. It's the seatbelt airbag thing that's situating it. So back to like the Newton's first law. But with this, because of Newton's first and second law, the inertia of the dummy continues to carry him forward, and then it takes him either a longer time or slower time, I'm not exactly sure, to then slow down and stop, because it will eventually hit the steering wheel and or windshield.
Okay, so in one of these it may take a longer time to slow down, and one of them may take a shorter time to slow down. Is that what you're saying?
Sort of, because the seatbelt and airbag kind of make it difficult because the dummies are the same. It's the same dummy, so it has the same inertia and mass. It's just that the seatbelt and airbag kind of prevent it from that inertia moving it forward.
Okay, so it's the seatbelt and the airbag are preventing the inertia. Can you tell me what inertia is?
Inertia,
like in your own words?
It's the speed, not the speed. It's the.
You're doing great. I appreciate it.
It's the speed that the mass is carrying it. So, it's inertia is how the mass is carrying the object and or thing.
Okay. So the inertia you think might be different for the two different dummies because of the airbag, or is the inertia the same?
The inertia would be the same. It's just that the inertia would be affected in the second model because of the seatbelt and airbag.
Okay. So like the seatbelt and airbag are going to be, and how might they affect the inertia?
They would prevent it from carrying the dummy. They would stop it quicker.
Okay. And then you mentioned that you're not sure that you know what Newton's third law is. So why don't you explain to me what Newton's third law is, and then...
Well, I know that Newton's third law is having to do with how forces equal out. So if for every force there's an opposite and equal force, but I wasn't exactly sure how to apply it as to why people get hurt in a car crash.
So in this situation... when the dummy is hitting, because you mentioned this earlier, the windshield and the steering wheel, what is the dummy doing to the windshield and the steering wheel?
The dummy is pushing, it's crashing into the steering wheel and windshield. However, then using Newton's third law, then the windshield and steering wheel would have to be pushing back.
Okay, so you drew one arrow here on this one. So what's that coming from?
That's coming from the steering wheel and windshield.
Okay, so that's coming from the steering wheel and windshield. So, and it's pushing the dummy. In which is it a forward force, backward force? What's the force doing?
Well, it's kind of hard to describe considering it doesn't say at what. It shows that it's when the dummy is hitting into. So technically, it would be in the opposite of motion.
Okay, sure. And then I noticed that this arrow, it looks like it might be a little bit larger than the drag arrow you drew before.
Yes.
Was that on purpose?
Yes, because the windshield and steering wheel are now going to later change the direction of the dummy, so it would be applying a stronger force since it's now slowing down quicker.
Okay. So you mentioned about how Newton's third law is equal and opposite forces. So you said that the steering wheel is putting a force on the dummy, and then you said something about the dummy doing something to the steering wheel and the windshield. Do you want to go ahead and draw in something else to show what you're talking about in terms of Newton's third law?
So if it were to be that the windshield is putting a force on the dummy and the dummy is putting force on the windshield and or steering wheel, then there would probably be a force either here and or at the steering wheel that would be going in the opposite direction, and it would be the same length or same amount of force on both.
As that one. Okay. Thank you. I appreciate that.